Ahmad, can you please check the message
Okay.
I've sent you? Yeah.
Thank you. Okay, I think we'll start. Thank you very much for joining us. Very good evening to you all. I would like to, before we start on the session, I would like to welcome all our members from Qatar. I would like to welcome as well the IOSH chair, Jason from the Caribbean, and I would like to welcome the members who are joining us from the Caribbean. I would like to welcome all our guests who are joining us from University of Qatar, from College of North Atlantic. So I think the topic is so important. That's why we are having lots of people from different entities, especially the educational institutions. So thank you very much for joining us this evening, and I'm pretty sure that we are going to enjoy the session. With that, I would like to start. For those who doesn't know me, my name is Ahmed Al-Idrisi. I'm the chair for IOSH Qatar branch, and I will be handling the first part of the session, and then I will hand over to the presenter, and then at the end, we are going to have a Q&A session that will be handled by my colleague Valentine from the executive committee. With that, I would like to go quickly through the housekeeping session. So for the housekeeping, as you can see in front of you, we have the mics should be turned off, should be muted during the session. Turn your view to speaker's view, only one speaker at a time. If we have time, usually in our sessions, we allow people to have like a kind of a direct discussion with the speaker. However, if the time is short, then we will take the questions and then we will handle them ourselves. You can choose to keep your camera on or off. The session will be recorded, so if you don't want to be recorded, then you can put it off. Please make sure that if you have any comments, if you have any questions, put your comments and questions on the chat room so that we can take them and pass them to the speaker. The meeting, usually we lock the meeting after 20 minutes. This is like Irish policy for security reasons. This session is our like first session for 2022. And we really wanted to start the session with an important topic to all of us here, a topic that we believe that it has not been covered properly before. And we brought a subject matter expert from Imperial College in London, Dr. Olga, to enlighten us on these important issues that are related to safety of educational institutions, mainly laboratories and so forth. So as I said, feel free to ask any question. And even if you would like us to hold like other sessions on this topic, let us know, because I know that this is a topic that has not been covered properly before, and it's very difficult to cover the whole kind of aspects in one session. With that, I would like to introduce Dr. Olga Kuzmina. She is a subject matter expert on this topic, and she's a qualified health and safety specialist. She routinely advises on handling, storage, and disposal of hazardous chemicals and support outreach activities. And as we know that dealing with laboratories in educational institutions or research institutions, we have these challenges of handling hazardous chemicals. She created an organizational policies on waste routes, safe solvent purification, safe chemical storage and disposal. She developed and delivered health and safety trainings. She was a winner of the 40 under 40 Outstanding Health and Safety Professionals Award in 2018. Dr. Cosmina is a committee member of IOSH Environment and Waste Management Group. And I assure you that you are going to enjoy the session. You will have lots of valuable information into the session. The session, as I said before, it will be recorded, and the recordings will be available on our micro website, IOSH micro website for Qatar branch. So with that, please join me to welcome Dr. Olga, and thank you very much for joining us. Dr. Olga?
Hello, everyone.
Yo.
Thanks a lot, Ahmed, for introducing me,
Yeah.
and thanks for hosting me today. As I was introduced, my name is Olga. I work for Imperial College London. I'm going to share my presentation slides with you today, and the recording together with copies of the slides will be then available for you online. So let me a moment. I'm going to share the screen. Here it is.
Okay.
Yes, you should be able to see the screen now.
Yes.
Excellent. So, as I told that today we will be talking about health and safety in the research universities. My background and why I am a subject matter expert, because I have myself PhD in chemistry from German university, and I have more than 15 years of experience within the research, academia, industry, and manufacturing. And from 2016, I work as a faculty safety manager at Imperial College London, that is the largest research university in the UK. And you can join me in my LinkedIn profile. The majority of the information that I will introduce you to today is taken or combined in the recent book that was published in 2020, which is called Challenges for Health and Safety in Higher Education and Research Organization. You can access this book on the Royal Society of Chemistry web pages, and the first chapter is free for download. And throughout the presentation, I will be referring to different chapters from there in this book, because this book is a collection of best practices that myself and my colleagues put together to ensure that health and safety professionals and staff with safety responsibilities in research universities are able to actually learn and implement in their organization. Because as we know, what is the challenges? We're all facing the same main categories of challenges. Such challenges include physical challenges, just our infrastructure. Our building can be old, our equipment can be aging, the progress doesn't stay in place, and the progress is developing. We have new approaches, we have new technologies. And however, we may have a lack of appropriate equipment and lack of space where we put this equipment. There are also organizational challenges, such as lack of clear guidance. You have a new equipment, but you don't know how to use it. And by misusing it, you are just waiting for accident to happen. You may have insufficient supervision and training, lack of accountability, and bureaucracy. Lack of accountability, I find especially important, because us, as a health and safety professional, are we accountable for health and safety in the research organization? Or is it actually researchers? Or is it their supervisors? So this needs to be clarified, and I will refer to it on my next slides. Then we have, all of us have economical challenges, economical barriers. First of all, we have limited source, limited economical funds in our organizations. Not many of us are lucky enough to have unlimited budget for safety expenses. Also, when our researchers in organizations, they are applying for research funding, there is no section in this research funding application that will tell you, and how much would you like us to give you to ensure that you put necessary safety controls in place. And the worst thing happens when the researcher gets funding to conduct the research and purchase a bit of kit, for example, high power laser, class 4 laser. And then to put this class 4 laser in the lab and make the environment safe, you have to spend another £1,000 on all of the shutters and enclosure system and all of the safety controls. And this is not put into the application. So this is the money that either the research group or the research institution has to find. Then there are behavioral challenges, because each of us have different attributes, different attitudes. Not necessarily all researchers have the same background, and they will come with them their work attitude, their work behavior, their maybe ignorance, maybe poor culture. And however, maybe vice versa, maybe they will be overconfident and they will challenge your advice. And finally, as a higher education and research institution, we will have our industry-specific challenges. For example, we are conducting, or researcher in our organization, conducting novel experiments. No one knows what will happen. This chemistry. So we don't know what will happen. We have to predict what will happen. And also the main challenge there is that the majority of hands-on stuff is actually done by whom? By the students. Students are the least experienced researchers. So of course there are postdocs who are working for years and years, and they are actually the powers that promotes the research. But a lot of research tasks are done by not experienced personnel, students. And also a lot of experiments that are going at the same time, they might not necessarily be compatible. So researchers working next to each other, they may not know what they are doing, but the other person is doing. And this can create an additional hazard. So why do we, or why should we bother? Apart from the moral reasons that we actually want all of our staffs and students to come home from work and study with the same number of digits that they came in the morning, but also there are financial and legal reasons. And I'm working in the UK, so I would be talking about it from the point of view of UK legislation. So UK legislation is quite developed, but it's developed and aimed on a large manufacturing sites where you have a lot of major disaster could be happening. It's aimed on a large transportation companies. It doesn't really aim the legislation specifically to universities and research organizations, whereas the research and use of hazardous substances happens on a small scale. So the main thing that we should take from the legal documentation is the requirement of the risk assessment. So as long as we are assessing our risks and put controls in place that are reasonable, practicable, we are doing everything in our power to ensure safety of our employees, students, visitors. So what is sufficient and suitable risk assessment? You have to assess the task and who can be harmed. And you have to deal with the significant hazards and ensure that the precautions are reasonable. And then you have to consider the level of detail. So if you are doing the risk assessment for an office area, for example, where students are using display screen equipment, the risk assessment could be quite simple. But if you are doing a risk assessment of a new process where you are using a laser beam going through a spray of chemicals, then you have to go quite into details what can go wrong. And you are not expected to highlight everything. You have to highlight the hazards that are foreseeable. And to do this, you need to communicate with the researchers who are actually going to do the task. So ideally, when they're designing the experiment, they have to come to you and get an advice. And in collaboration with them, you are conducting risk assessment. And what does mean reasonable practical? It's that you are not required to implement a control that is possible. you require to implement the control which is on the basis of expense and complexity is the most suitable. So if further improving of safety involves a ridiculous investment or ridiculous effort, you may not go this extra step. So let's go to the next slide and start from the beginning. What is the beginning? It is laboratory design. Not all of us have this luxury of being able to contribute to design at a design step of the laboratory. Majority of us will come into workplace and we will already be given a laboratory or a space, a workshop that is already there, and we will be asked to conduct risk assessment or to ensure that it's safe to work there. However, if you are working as a health and safety professional at an organization, make sure that you are communicating to people involved in the design or redesign of the premises and to your project manager, that they consult with you when they are starting to redesign or put new things into place, because it's very important. And as we see on this picture here, this is a premises laboratory where you will are able to see a piece of the lab with a fume cupboard. You all can see fume cupboard, bench. There is a piece of rotovap standing here and a bit of chemicals. And what you see on the right-hand side, and on the right-hand side, there is an office space. So this is the laboratory, this office, and you would be able to see this a lot happening, especially in the last century, where it was absolutely normal to have office within the laboratory. Nowadays, we are trying to go away from this. We are trying to separate office space from the laboratory. Why we are doing it? I think it's obvious to avoid the cross-contamination and exposure of the researcher in the office to the laboratory hazards. For example, here, we don't know, are those chemicals hazardous by inhalation? Then just sitting here, this researcher is exposed. Or if it's not hazardous by inhalation, but it can be hazardous by other routes, by standing and wearing their clothes, outer clothes, they can cross-contaminate it and bring this hazards, this contamination to their home and expose everyone in their home environment to this hazard. We don't want this. So if we are talking back about our risk assessment, reasonable, practical, what would be a possible outcome to resolve this design fault? Ideally, you would remove the office space and put it in separate room. This was exactly what was done for this particular place. They removed the office desks and relocated it to another room and put more lab benches in this room. However, this may not be the case. Maybe you have economical barriers, and you have if you have economical barriers, you have to go further and think about what else you can introduce. Maybe you would like to put a wall in the beginning here, so a wall next to the fume cupboard. What then you can consider? You should consider, is there enough space between the wall and the cabinet for the airflow? Is it enough space between the wall and the office desk for the access and ingress? So everything that is listed in this table 13.1 here from the chapter 13 in the book is something that you have to consider when you are designing or redesigning the space. So in this case, the possibility is to put the wall here, and if the wall is not possible because of the space constraints, for example, then what's the next step you can do? The next step would be involved to review what activity is taking place. So this is a thing that while you are thinking about laboratory design, you're also conducting a risk assessment, and vice versa. While you're conducting risk assessment, you are thinking about space where these activities are taking place. The most common mistakes in the lab include, as I told, lack of adequate storage space. So this is resulting in a poor housekeeping and inefficient use of materials. Lack of adequate exposure control devices. So for example, fume cupboards, glove boxes. or also inappropriate use of them when they're too cluttered, and then when they're used as a storage space rather than a workspace. Then we have another mistake, is inadequate flexibility. So what is it in this picture here? Is it office? Is it a workspace? We can see that there is a microscope here. There are some reagents here in the different containers. There is a bit of a glassware. This is a chemical lab sink. You have another chemical reagent bottle here. But on the other hand, we have a kind of paperwork, and we have furniture which is not really suitable for laboratory. Look, the furniture here has materials which are easily combustible and also can be penetrable by the chemicals. So we need to make sure that laboratories are looking like laboratories. So you have good housekeeping, you have flexibility of keep the right equipment there, and you have access and provision of the emergency equipment. So in this example, we see a lot of pieces of equipment that is probably not in use and reagents that are standing around. So how we can go and improve our situation in the lab with legacy reagents and equipment. This is a first step if you are inheriting the lab from somewhere. You are looking into this space and you are deciding what you actually can get rid of. Because the less thing you have in the space, the less hazards there are and the less risk you are exposing yourself and researchers. So I believe that majority of us have situation in the workplaces where we've seen such an example of storage of chemicals, where you cannot really read the label because the chemical is so old, where the chemicals are just stored on the shelves and bottles are laying around without being upright stored, where there is no approach, no structure to storing. You just store everything in one room and without any kind of precautions, alphabetically perhaps. Or, for example, storing it on a open shelf when the chemical clearly has health hazards and can be hazardous by inhalation. So to avoid this, you need to address legacy reagents and equipment. In the UK legislation, there is a piece of regulations called Dangerous Substances and Explosive Atmospheres Regulations. So these regulations highlight that one lab can have up to 50 liters of flammable materials. Everything above this should be stored in a specific flammable cabinets, rated and standardized. So to make sure that you are not going above this and that you are storing only chemicals that are needed, what questions you need to ask your researchers? You need to ensure that you are collaborating with them and not mandating them. So it will be a nice exercise to do together with the owner of the place. So ask them questions about all these chemicals, a list of chemicals, how likely they are going to use them again. Is it likely to be reused? How long will it last and how hazardous it is? Will it generate any new hazard? For example, IOSH 019, this is a hazard phrase that can be found in the SDS. SDS, I believe you all know, but I will tell. SDS is a safety data sheet, and this is a document supplied to you by the manufacturer, which explains what kind of the hazards and precautions are expected to be done when working with this chemical. And IOSH 019 means that the chemical is potentially peroxide forming. Majority of the organic peroxides, they are explosive on impact. So if you have formed, this is a picture of the bottle with peroxide formed. So if you have this kind of peroxide formed around the neck of the chemical bottle, at the attempt of the opening this bottle, it may explode. And as a result of explosion, it can not only damage surrounding, but it can injure the researcher. And this is what we want to avoid. So if you know the hazards, like this hazard of your chemical. Are you going to check it somehow? Are you going to do this regular check on them, on the formation of peroxide? Are you going to dispose of them? And if you're going to dispose of your chemicals, how much will it cost? And here we need to ensure that we facilitate the disposal procedure for the researchers. So perhaps collaborate with your waste contractors and ensure, ask them how you make facilitated, how you may make sure that disposal of the chemical is easier and cheaper than quenching of the chemical, because a lot of chemicals researchers in the lab will want to quench, so render them non-hazardous, but the quenching process is very much hazardous process itself. So if your waste contractor is agreeing to take stable waste without quenching, it is very good solution for researchers as well. And what recommendations can you give to your laboratory users? To control the acquisition of and sharing of chemicals, so to not overbuy chemicals. Do not buy 1.5 liters of something when you need just a few milligrams. Make sure that you introduce it in the culture. Keep up-to-date inventory, because inventory is important, and there are a number of ways how you can keep it. There are free software that can help you to do it. You can actually use Excel. A lot of small labs use Excel spreadsheets, but there are also paid software for large organizations. Perhaps paid software is something that is more useful to look at, because it also provides not only inventory module, but other modules that may be of use. Introduce exit lab procedures. Put in place procedures for the researchers who are going away, and make them clean up after them. To talk to their supervisor and decide, do they actually need to store these chemicals, or if the project is closed, they can dispose of it. And if they store it, are you sure that the next person working on this project will want to use the old chemical? A lot of synthetic chemists, when they're starting somebody's projects, they prefer to buy new chemicals rather than reusing existing chemicals, because synthetic chemistry is very sensitive. And if you have a contaminated product, the outcome of your reaction will be different. So a lot of those chemicals started to get copied, and we will have a lot of bottles of the same chemicals. No one will use the original one. Everyone will get a new and new and new. So please ensure that your researchers are aware that this is not a good approach, and that they need to dispose of the chemicals that they are not using. And as a part of PDCA, which we all know, plan to check out, as a part of this cycle, you need to inspect and audit. So dedicate some time, especially if you are supervising, if you are working for an organization which has research lab, introduce an inspection schedule. Come there and check physically what is the state of their inventory, what is the state of their chemicals, what is the state of their equipment. And with regards to the equipment, it's very easy. It's if you can decontaminate it, then you can have an option of selling, donating, or disposing of it. If you cannot decontaminating, there is no other option. It only can be disposed of as hazardous material. And in this case, you have to discuss with your waste manager how to render it, pack it appropriately for them to pick it up. And it will be much more expensive. So with regards to the storage and inventory management, probably the most famous approach is the Stanford approach of compatibilities, where depending on the hazardous property of material, you can combine storage of chemicals. For example, you can have organic bases stored together with flammable, but not very reactive, and organic solvents, as here you can see on the shelf A, on the top shelf, A, G, and L. And you may have a special case for them separated in the special containers, which is also a spill tray. And while it's not a bad approach, it's very generic. So based on this approach, I would recommend, especially for the large quantities, large inventories, to go deeper and to base inventory on the age phrases. So again, going into the SDS, you can look at what age phrases, what actually particular hazard is there for the chemical, and then based your storage location on this hazard. So the flow chart that is provided on this slide and will not probably be visible to everyone, but you are able to download the slides, and then if you really want, you can approach me for a copy of this flow chart. The point is that with this flow chart, you not only segregate and separate the hazards by their properties, it also provides you with an advice of where to store it. So not just in the like in the main guide that we all know, like top shelf, bottom shelf, but actually what kind of storage. Does it need to be metal? Does it need to be flammable rated? Does it need to be ventilated? What kind of material? This is more of what we are looking for in the laboratories. And if you do not have storage that is required for your chemical inventory, acquire the storage, get specific cabinets. So here is on this slide presented some examples of the cabinets, and it is a ventilated glass-fronted storage cabinet. Ventilated, you can store all the hazards that are hazardous by inhalation. Then you can have a flammable, which is also flammable rated storage. So if something goes on fire inside, there is a special seal which will seal it in, and the rating is 90 minutes. So for 90 minutes, it's guaranteed that the fire doesn't escape. Or it's also important to ensure that you are segregating the hazards by secondary hazards. So for example, if you have all the cabinet here, which is probably ventilated, and you store their hazards, inhalation hazards, each of these box will have different secondary hazards. So it may be hazardous by inhalation and corrosive, or hazardous by inhalation and oxidizing. It cannot be hazardous inhalation and flammable because the cabinet is not metal cabinet. So this is again coming back to the flow chart. It's important to understand what kind of storage location is required. But if we're going now outside of the classroom, so going outside of the classroom, what else is expected from us to look at as from the point of health and safety professional at universities? Universities and research organizations have a variety of activities which take place outside of the research lab. It can be sporting activities, it can be work and student experience placements when you are going from one research organization to another, and it can be field work safety. There is this hilarious videos that I always start for my courses on the field work safety. And it's just a video, a few minutes video. Please find it on YouTube and click on the link when you are getting the slides. It's about two gentlemen who were wearing the costume, zebra costume, and walking somewhere around real zebras. Like, it was for fun, until a pride of young lions came and attacked them. And luckily, they all survived, so it's all was okay. They survived. They had a lot of other videos filmed later on after this incident. But this is what, again, shows you how important the correct risk assessment is. What not to do when you are, what silly things not to do in order to get your research done. So this is something that we also have to consider as a health and safety professional. You need to educate our students, our visitors, our researchers, what they have to think about the mindset. And a lot of the details are given in the chapter 8 of this book that is available on the website. So if you are looking into this, please go and have a look at this chapter. How are we achieving all of this? Important thing is to train everyone. And we have this huge challenge because in research organization, especially at universities, we have a constant turnover of the students. There are not many students, not many researchers who stay longer than 3-4 years in one university. So every 3-4 years and more often, you have to repeatedly tell again and again the same thing for the new students, and they learn it, and you think, oh, everything works okay, they know what to do, and they leave. And new people are coming who are again clueless about how to do. So this reiterated process of learning and training should be continuous. And there are 3 aspects of the training. One aspect is compulsory compliance to all staff. There is a job-specific training, and there is additional training and guidance. So compulsory training will include job and responsibility, and this is a very clear message should be given relating to expectation of what are the health and safety duties to all of the staff. Of course, what we are saying that everyone is responsible for the safety, their own safety and those around. What does it mean? That we need to, or researchers need to assess their activity and ensure that they are safe. But ultimately, who is responsible for their safety? Ultimately, the organization and their supervisors are responsible for the researcher's safety. And as an example, I included here a brief from the UCL, University of California, Los Angeles, where they had in 2016 a fire. And in this fire, unfortunately, a researcher was killed. And the professor who was supervisor of this researcher was trialed because he didn't ensure the safety of the researcher. In addition to this training, there are some more specific trainings such as risk management, accident incident reporting, fire, first aid, manual handling, and DSC. So all of these trainings have to be done either online or as a workshop or as a combination. Most often the hands-on experience is the best way to learn, but it's not always possible. So there are examples of the safety training sheets that will be available on the slides. I'm not going to go into details now, but it is examples of what procedures, what health and safety trainings could be provided and how often they should be refreshed. How they are expected to communicate. Most important, the line manager should be responsible to communicate to the new employee about the expected training, especially health and safety training procedures in the organization. And the scientists and health and safety personnel should work in continuous cycle to ensure that they collaborate effectively and talk to each other and know what are they doing and what are expectations of them in order to do the work safety. As an example, I provide here posters that is a communication example that we were sending out recently to our students because there is always this communication discussion about what can I wear in the lab. Especially it will be relevant in warm countries or in buildings with bad ventilation. And this is going back to our discussion about design of the lab. Ensure that your laboratory's design is appropriate to the activities within. So it should not be very hot. Then your researchers will not be prompted to take off unnecessary clothes and will be able to work in the fully closed attire. So you will not have situation when people are coming in the flip-flops. So this is an example of a clear message that you are sending to your researchers that has a text, has a visuals, and doesn't have too much information. So think about this methods of communication and communicate effectively, train your researchers. What do you need to look at else apart from communicating within your organization? You need to think about communicating outside of your organization. You may have to consider to have an agreement with external emergency services. And depending on what hazards you have in your organization, you may have to consider the provision of fire wardens, fire aiders, and emergency responders. So first of all, contact your nearest fire department or nearest fire office and collaborate with them, because I'm sure that you have in your organization the majority of those fire causes. And by providing training to your researchers, especially it's hands-on training, you may be able to ensure that they can finish or put down the small fire. But if it's a fire serious, you cannot expect your staff to fight the fire. You have to involve the outside properly trained professionals, firefighters. Another important thing is a spill response, especially if you are working with hazardous substances, you need to ensure that you are having provision of spill kit. And there are only three things that you have to have there. You have to have something that absorbs the spills, something that can contain the spin like a bag, and something that a tool to help researchers. So for example, the gloves to protect them. And the combination of these three types of the gloves, the nitrile, rubber gloves, and the silver shields, are very chemically resistant. You can probably deal with all spills by using combination of these gloves, but then you have to provide additional training in use of PPE and ensuring that as soon as the researcher or responder notices that the PPE is contaminated, they have to be replaced, because gloves do not provide the protection. It's a final protection. It just provides protection against splashes. Also, as a part of a training, you need to understand give an understanding to your researchers when they have to tackle it themselves and when they have to just step back and leave the emergency services to come and deal with it. Of course, you need to have a provisional spill kit, and on the slide, I'll present the bare minimum of what you have in a spill kit. Very often, there is a burning part, not burn, anti-burned or after-burn part in the spill kit, or spill kit, first aid kit. So those after-burn parts, they contain the hydrogel. However, this is only for cases where you do not have access to water. There is nothing better than a water in a burn. The burn cooling and hydrogel pack is only good after you already water it. So if you have a burn, or if your researcher has a burn, the first response should be to always go and to rinse it under the tepid water. And then the lessons learned, examples of good practices. So in this slide, there are a list of practices that some universities use to prompt researchers to report incidents, and then to discuss it between research groups to ensure that no one intentionally or by not knowing that this is possibility repeats it. And then you can also spread it more. There are a number of forums, especially in the UK, there is a forum, Chemical Safety University Forum, where you can be added to distribution list and discuss the incident that happened in your organization to ensure that other people are aware and it's not happening again. What is most important is that you're not only seen as a person who is policing health and safety, who is going around and saying like, because this is wrong, this needs to be dealt differently. But you need to be seen as a person who is highlighting and celebrating good practices. So if you see that somebody is doing something well, just highlight it and bring this to a committee and tell, like, for example, in this group, they do not put in one fridge oxidizer and flammables, and they mark this fridge that it is only for flammables, fridge for flammables, and this is spark proof fridge. This is good practice. Let's tell let's tell others about this and distribute good practices. And also a good thing is to go to other departments and other organizations and see how it works there. So use your connection, use your networks, collaborate, and just go and visit other universities. As I mentioned before, the best training is hands-on training. So if you are going to other places, see how it's done in other places, I'm sure you will learn a lot. Well, that's all. Thank you very much. Do you have any questions? I will be happy to answer.
Thanks, Doc. For every one of you that have turned in with your questions, we would run through it now. Dr. Olga spent such a long time trying to explain all this, and I'm sure that we got the message very clearly about laboratory and research safety. Now we've got about 7 questions. Let me take it one by one. The first question was, what authorities are there for waste management, especially solid waste? and hazardous waste?
So I will talk about UK authorities because this is where I work. Unfortunately, I'm not sure what is the situation in your country. But for the UK, it will be Health and Safety Executive, HSE, and it will be Environmental Agency. So majority of the cases will go through there. Regulations and laws. So it depends on what release is expected, because, for example, this you will have to have a special agreement with your waste contractor, with your water waste contractor. For example, we have Thames Water, who is our provider of fresh water and who are picking up our wastewater, and we have an agreement with them that only, I don't know, up to certain concentration of, I don't know, this kind of waste can be found in the sample, not no concentration of this waste can be found. And if they do sampling and they find that we are exceeding these limits, we will be fined. So in this case, it will be depending on what route of waste you're looking at. With regards to the hazardous waste contractors, it is very important to make sure that you are employing a professional who is qualified and skilled in it, and they will help you to be compliant with the hazardous waste legislation.
Okay, thanks, Doc. And I think for those in Qatar, you know that we have the Environmental Protection Agency, we've got the municipality as well. So these also are authorities that one way or the other control the waste management regulations here. The second question is, what regulations or laws are there to register carriers as well as set standards for various release? I think this question is indirectly tied to the first question. Doctor has taken care of it. We'll go to the third one, which is how often and what tests are carried out to measure the hazardous contents in the atmosphere?
It's a good question, and it should be defined by your risk assessment. I know that it's a very vague answer, and this is what you're not expected, but you need to look at what you are working with. Example, in one of our buildings, we work with lead components. And of course, you know that lead can bioaccumulate in your body and then affect you negatively. So the amount of lead particles on the surfaces and in the air should be examined. So there is a schedule of wipe test, I think that they call, where a trained professional from our department will come, conduct these wipes, check the concentration of the lead on the surfaces in the air and report it back. And if they found any concentration that is above the established limit, they will then request us to review our risk assessment, stop all the activities, review risk assessment, and ensure that the new controls are introduced that prevents an exposure. So there is no direct answer that every 3 months you have to measure hazardous content in your workplace. No, it depends on what you are doing.
Absolutely, absolutely. Thanks, Doc. The fourth question is, what kind of fire suppression system is recommended in a lab, considering the lot of chemical storages that are inherent in that lab?
Yes, good question. I think that the best system, one of the best system will be the water sprinkler, because two reasons. First reason, it is a reliable system, especially if it's connected to your mains, so there is unlimited water supply. And second, it is localized, so it is going straight into the area of your fire, source of your fire. Of course, it will be not as useful if you have pyrophoric or water reactive materials, because it will maintain the fire. In this case, for this kind of storage, if you have a concise storage of water reactive or pyrophoric materials, you can install there a CO2 suppression system. It is very good to consider installing the fire suppression system within the fume cupboards, because we have a lot of fires appearing in the fume cupboards. And then if you have a fire suppression system installed in there, you just shut the sash and let the fire suppression system within the fume cupboard to deal with it. The drawback of the fire suppression system, especially if it's a powder system, that the fume cupboard remains ducted, and then it's all this power goes into the duct system and block it. So you will have to call for engineer to then clean it up and return it as a
Understood.
normal operation. But I think that what you need to consider is what kind of chemicals and if the water sprinkler system will be sufficient for them. And then if you have an electrical equipment or expensive equipment in the area, you will not want to have water there, or you may want to have a system which requires manual switch on. So it will tell you that there is a fire. If you would like to activate water sprinkler, press this button. Then it will give you at least chance to do an assessment. What is how large fire is, and what is if it's appropriate to use water at this very moment.
Absolutely, thanks, Doc. We've got another question here. This is, do we have face masks for the lab assistants, the people in the lab as part of emergency response plan? I think this has already been taken care of doctor's response when she talked about the dress codes in the laboratory. So
I would like to just do a small comment here. Face mask from the point of view of COVID, for example, when it's you're standing next to somebody and that's why you want to wear a face mask. If you're working in the environment, in the laboratory where you have a lot of wet hazards, a lot of solvents, then it's maybe a good idea to wear a face shield. So not only mask, but face shield, because if you spray chemicals, you may not notice that your mask is contaminated, and then it going to permeate your mask and go into your skin, especially in this area where it's mouth and nose, not good. Another thing, if you are wearing mask for COVID reason in the labs, make sure that it's disposable. So you are taking it off and dispose of it as often as you can, exactly for the same reason. So because if it's contaminated, you will not know it, you will not notice. And you should, if it's face mask from the point of respiratory protection, you should first of all make sure that your lab doesn't need to have respiratory protection. So you should have to go the hierarchy of controls triangle and think, do you need this hazard? If so, then use engineering controls, use fume cupboards, use microbiological safety cabinet, because the face mask, if you are wanting to protect yourself from the respiratory hazard, it's PPE and it should be your last resort. And if you are wearing it for this reason, ensure that everyone who works next to you also wears the same respiratory protection.
Absolutely. Thanks, Doc. Thanks, Doc. Now we've got a few more questions. I think the questions are just trickling in now. Let me try to run through this. How the risk is assessed and how the staff being educated, considering researchers as audience, and each chemical, sorry, I think I have to rephrase this. Someone is asking how risk is assessed, I think at the research level, and what, considering each chemicals that has got its own hazards, what kind of skills is required for trainers in such an environment?
Yes, it is. You cannot train everyone to know and to remember hazard of each chemical. I worked in chemical area, chemical background for more than a decade, and I don't know all the chemicals hazard. Of course, there is something that comes very often, and I just like, oh yes, I know this is like explosive, or I know this is toxic, but it's something that you have to have a habit of looking into SDS. Of course, SDS, safety data sheet, is not the last resort, but it is the first thing that you look at. So you have to look at the chemical bottle, because you will have an emblem on the bottle explaining what it is, what kind of hazard it is, and then look into SDS and read further. What skills you need to have? Ideally, your supervisor, so the supervisor of the researcher, will have enough knowledge of these chemicals or of the class of the chemicals to help to do risk assessment. But if not, you can look for the, as I told, the networks, for example, University Chemical Safety Forum. There are literature resources, like, for example, KNOVL, so KNOVL. So KNOVL, this is a resource, literature resources. You search for reagent there, it will show you what what kind of reaction it can participate in. So probably the main skill is background knowledge of chemistry knowledge, but from the point of view of health and safety professional, it's just normal skill of making risk assessment, assessing the risk, consulting with people who know the task, assessing who may be harmed, and seeing what controls you have in place. So skills that you probably already have because you are in this profession.
Absolutely. Thanks, Doc. I think I'll take three more questions if you still have the time. Emergency response and management, part of the protocols for students and researchers conducting field trials. Mm-hmm. How does this cover personnel conducting research in foreign countries which may not have adequate HSE legislation as are those in the UK?
Yes. So when your researcher is planning a trip to another country, they should come to you. Well, first they should come to the supervisor and discuss the research aspect, but then they should come to you as a health and safety professional and get an advice. And apart from providing advice with regards to general, like the country where they go, what is the political situation there, is it needed to have special precautions, it's good to have this understanding if it's what is their level of health and safety requirements. And it's good to have a conversation with the host professor or host supervisor, because when researcher goes to another place, they usually assign host supervisor. It's good to have a conversation with this host supervisor, what kind of risk assessments they have, what kind of procedures the researcher is expected to do there. And if they do not have risk assessment in place now for these procedures, to talk to the researchers and to ask them to not start the task until they conduct risk assessment, and to leave your contact to them so they can remotely email you or have a Teams meeting with you and explain what tasks they are going to do so you can help them to do risk assessment. So yes, the hosting organization will be responsible for this researcher while they are doing the work there, but it is your responsibility, or it is your organization responsibility to make sure that you do as much as you can to support them there.
Absolutely. Thanks, Doc. Now, another question about storage of large amount of ethanol on site in the UK. Is there any limit?
As far as I remember, there is a limit of 50 liters if it's not within the specific fire-rated cabinet. So depending on what type of your storage location, if you, for example, have a whole storage shed which is fire-rated, perhaps inside you can have more than 50 liters. I will not go into these details. I'm not sure on the answer.
Okay. I think, yeah, you might be correct. It's on a case-by-case basis, but basically the minimum acceptable is 50 liters. You're correct. A couple of more other questions. What is the most challenge in research labs related to COVID-19 control measures?
Luckily, in research lab, you should have adequate ventilation. So the requirement for the UK is to have minimum 6 air changes in the laboratory. With this type of ventilation, you do not expect people to need to wear a face mask, because it's quite a lot of air change, and in all cases, it will be a fresh air change. So probably the most challenging part is lone working and working close to each other. So sometimes researchers need to get really close to explain the procedure or to show something. In this case, yes, wearing face mask and shield is useful because they are still too close to each other, and despite the number of air changes, they are quite close, and especially for a long time. So then this is useful to have an additional controls. And lone working, because a lot of researchers are getting ill, a lot of researchers are spending more time on writing up their research instead of doing the research on site because of the traveling and working on site communication. So to prevent this exposure, researchers taking a step back, and a lot of them working from home. There are a lot of situations when some students, some researchers who are finishing the project, they're staying working alone, and especially when they're staying late alone, the lone working is a big challenge. You need to look into your procedures and explain the researchers that there is a risk not only because they are doing something hazardous, that something can happen and it affects them and nobody is here to help, but even simple thing like we had a situation in one of my workplaces that a researcher just left the phone on the bench and left to the toilet, and she was locked in the toilet for the night because no one knew that she's there, and the lock broke, and they called on her phone and she didn't pick up, and only in the morning somebody found her in the toilet. So it was not the best experience, and this is another phase of the lone working, something that needs to be considered.
Absolutely. Thanks, Doc. And the last question for this session would be, is there any concern of what's this? I'm not too sure what this, okay, this has to do with ventilation that is used on site. I think there's a challenge with the question, so I'll just keep it down. Let me see if there are any other further questions. At the moment, no question. Thanks, Doc, for this interesting, entertaining, and very participatory section. I think it's research and laboratory safety is more of an extensive topic. For you to be able to congest this within a short time, this is highly appreciated. Over now to Ahmed. Let's wrap this up, please.
Thank you. Thanks, everyone.
Thank you very much, Dr. Olga, for this very interesting presentation, very informative, and I believe that it was interesting to the extent that Valentine went above time, you know, so went beyond time. So thank you very much for this interesting presentation. It was really nice. You have covered more or less most of the issues, and as I said, you know, it's impossible, you know, to cover the whole context of this in one session. However, as I said, you know, we might reach out to you again, you know, for another session. So anyway, I would like to thank you. Yes,
please do.
Sure,
please distribute
sure.
the slides, and it's
Yes,
also
sure,
have
100%,
links and for
100%.
more information
Absolutely.
there.
The
Thank
slides are going to be, the slides and the recording are going to be available on our IOSH Micro website for Qatar branch. If anybody out of this kind of cycle, you can communicate to us directly through either a message on LinkedIn or on our LinkedIn web page, so that we can send you the slides. So with that, I would like to thank you all for your attendance, and wish you have a kind of a good evening, and thank you very much, and looking forward to see you in our next session. Thank you, and Happy New Year.
Happy New Year
Thank you
all.
very much.
Bye.
Thank you very much. Bye.